Okay, it's actually recorded. So that's fine. So just like we were saying, we need to inspect the surface of the solar panels. This is a typical example of a cracked solar panel. We were talking about the MC4 connector in the previous session. This is a typical, this is called an MC4 connector used for solar installation, solar, what do we call it? Solar panel termination. They come like this. So there are instances where, especially, we consume a lot of used solar panels here in this part of the country. Most of them don't come with this. It's actually not a must, but if you have new solar panels, they should come with this because it makes the installation better, easier, because it's more of a plug and unplug connector. So it makes the installation easier, and it also makes your termination firm. It makes your termination firm. So those are the things. There are also there are instances where you have a lot of parallel series connection, a lot of parallel connections, all coming out as out from. You have a lot of parallel connections. They could. Sorry, I'm trying to mute somebody. Okay, sorry. So, okay. So these are MC4 connectors. New solar panel comes with it. So there are cases where you have a lot of parallel connections coming from multiple string of solar panels. You use this type of connector to link them up all together. So if you have, like in this case, if you have four strings of four strings of solar connections, and you want them to come, they will all come and terminate here and have a common output. Then the same thing, one for the positive and one for the negative. So they will come in here and go out here. So the MC4 connectors, actually, this is a multi-branch MC4 connector. It's called a multi-branch MC4 connector, while this is just an ordinary MC4 connector, this one. So the multi-branch actually helps you to link multiple strings of solar panels together. So the fact remains, why all these connectors is because we want to ensure that our connections are firm, our connections are good, so that we don't have a partial contact, as the layman will also always say it. It's actually called aching effect. We'll talk about it, and because it's one of the major cause of fire incidences in electrical systems. So let me just use the word partial contact, since we have a lot of people here that are just that want to learn about it. This helps in eliminating partial contact or reducing the risk of partial contact. You understand? So this is a multi-branch. When you have a lot of strings, this one combines them together and give a common this thing. So these are the we need to check all these things properly for safety. You need to check the connectors that the panel came with, and you also need to check this properly when installing, so that at times, please, if you're using especially a panel that is not used, it's not new, a used panel, you need to check this thing very well. I have had incidences whereby there are rusts in these particular connectors inside. So if you connect them, you will find out that the efficiency of the system will not be good. It will affect the efficiency, or it may even cause the partial contact we're talking about, and later it may even cause fire incidents. So you need to check, have a look at it inside the connector. You will see whether the connector is okay or is not okay. You should be able to see. A physical inspection will tell you whether the connector is okay or is not okay. I have had incidences like this that I had to do away with them. It happens, especially if the panel is not new panel. Used panels we use in this part of the country. in this country. A lot of the panels we use now are fairly used panels. So that is it. So let me look at what next. So now the next thing we will be, is there any question on this, please? Before we look at, is there any question?
Yes, a question, sir.
Okay, sir.
So you talked about panels, used panels that have rusty MC4 connectors.
Yes, sir.
In that case, what do? You don't take that panel, or is it possible you cut and connect a new one, or how is it?
Yeah,
If you encounter something like that from the supplier.
yes, that's good. Thank you for the question. If you want to still maintain the MC4 connector, you know, the MC4 connector, if you have another MC4 connector for replacement, you can actually replace it. You can replace it. You understand?
Okay.
If you don't have another MC4 connector, then you will be left with no alternative than to use the cut and join way of doing things, or the cut and join formula. Okay. You understand? But we'll still come to that proper when we reach proper termination of cables. You understand? We'll come to how you properly terminate cables. You understand? So that is it.
Okay, sir.
Yes, sir. Any other question? So, in the absence of none,
hello,
of any, sorry.
You showed a broken panel, but
yes,
you didn't
sir.
talk much of
it. Thank you,
in
madam.
an event of that, what do you do? Do you change the entire panel?
If you have a broken panel, the best thing to do is to change it, because number one, it affects the efficiency. You understand? It affects the efficiency of the system as a whole. A system, you know, a solar panel actually sun rays that travel in straight line. We all know the rectilinear propagation of light. That's light traveling in straight lines. You understand? So when this light travel in straight lines, as they move, hit your panel, any crack on the panel will definitely reflect back the rays of the lights that are falling on this panel in linear form. You know, these lights, with this light falling on this solar panel, move in straight line. So as they come, they're supposed to meet the glass surface smooth. When the glass surface is smooth, they will penetrate the glass surface and then hit the surface of the semiconductor materials used in making the solar panels. That is the that is where how the energy is being. When this light fall on some materials, they generate electricity. So, but once there's a crack on these solar panels, you understand, it like deflects this light that fall on straight lines. Instead of it reaching the surface of the silicon materials, some will be deflected. It's not all, mind you. Some of the lights will now be deflected or reflected backward. You understand? Once they are deflected, you should know that it affects the efficiency of this panel. So if a panel is rated 200 watts and it has a crack, know automatically that you can never get 200 watts from that solar panel. You understand? Is it clear? That is number one aspect of it, efficiency. Hella, I'm seeing your hand. I will come to you, please. Let me answer Mr. Lawrence's question. Then the second...
No, it's clear. It's clear.
Okay, it's clear. Okay. Then the second thing is, you know, these materials, once it cracks, it already this glass on the solar surface is actually an insulating material also for the semiconductor materials that are inside. You understand? It's an insulating surface for the semiconductor materials that are inside. So when those glasses are, once the glass surface is broken, if water falls on it, know that that water will definitely enter and get in contact with the semiconductor materials. We all know what happens when water fall on electrical materials. Are you with me? There's definitely going to be the risk of what? Fire. So that is why I talked about proper inspection of solar panel. You need to properly inspect it because it's a potential danger for any installation. If there's a crack on the solar panel and you install it, water ingress falls on it, touches the electrical surfaces, you understand, electrical surface of the semiconductor materials on the solar panel, you should know that there's a risk of fire hazard. So please, for two things: number one, efficiency; secondly, the risk of fire hazard. So the best thing for you to do is to replace any broken solar panel on any broken solar panel detected at the point of installation. So any other question?
Well communicated, sir.
Sir?
Well communicated.
Okay, that's lovely. That's lovely. So the next thing is the next thing we're going to be looking at, if you inspect those two things, just like Mr. Goshi said, concerning the solar panel, the best thing to do is, if you have a faulty, broken solar panel, is to change it. Then concerning connectors, if you have MC4 connectors, you can replace them. If you don't have, then you have to cut them off and use the cut and join method. We'll come to that. The next thing is fasting of solar panels. We're all talking about safety. You know, safety. You don't expect you don't go and install a solar panel that will be falling off tomorrow on somebody's. You install something on somebody's rooftop. You understand? A typical example like this is the picture I shared with you earlier, where we assemble that scaffold, where actually where cars used to be parked, you understand? So, you know, obviously, if we finish our installation, those cars, looking at the nature of that building, you know, it's a big man's house. He may be parking his expensive cars on at that point. So if you don't if you don't do a proper work, if a solar panel falls off from the rooftop and falls on his car, or falls, if you talk of that is even talking about car, if it falls off on somebody's head from that height, so it becomes a problem. So another thing we need to look at in this in solar panel installation is how secured are our panels on the rooftop? How secured are our panels on the rooftop? We talked about installation of rails. Some people install, I've seen where people install rails, they use nails to hit rails on the roof. Some, you understand, use rails, but left to me, you need to screw those rails to the wooden frame of the roof. Because once it's screwed, you know what it means. And the screws should have rough thread so that it screws right into the wooden frame of the roof, and it becomes hard for it to actually get pulled off by wind or by any external force. So please, when installing solar panel, we have to look at from our rails to our solar panels, we have to ensure that they are well fastened on the rooftop, please. I just hope I have, okay, let me see if I have pictures of, let me see if I have pictures of how, like in this, that case, let me see, okay, let me see, okay, just hope I have a good picture of, if you look at this picture very well, look at in between the solar panels, you see there are particular bolting screws or particular specialized, what do we call it? A specialized bracket that holds the solar panels. Are you seeing me? Are you seeing it? If you look at it here, you look at it here, you can see.
Yes.
Yeah,
So
we are seeing it.
these are very, very important things to take note of, because it's not just about installing. You're going to install this thing. These things are going to be there for 20 years, 30 years, you understand? So this thing needs to be fastened. You have to be sure that they are actually properly fastened to the rooftop. So the one I think there's the one we usually use here. on our own installations. If you look at, okay, if you look at, sorry, I don't know, it may not be legible. What we actually use here in our own case, what we actually use here is we use from the frame of from the rail, we have a projected bolt and nut at each edge of solar panel. So on that bolt and nut, we use a very big flat washer. You understand? A very big flat washer that presses the solar panel to the roof, to the solar rail. Then we screw them, we tie them. Then at the tail end, we have our locking bolts. At this end here, we have the locking brackets. Let me use the word bracket. We have a locking bracket so that, these ones are just pressed by washers. So if you don't lock them at this end, they can easily slide off. You understand? So after installing after installing all these ones at each point, at each edge, we have a big washer with a projected screw, which we tie it together from the rail. Then at the end, we lock them. We lock them with a locking bracket, and we ensure that it's properly locked so that it doesn't slide out. Because if one panel at this end slides out, definitely it will create space for others to easily slide off and fall off. So after installing all the solar panels and locking them with our big washers, we ensure that at the end we lock them properly. In fact, we concentrate a lot at this end to ensure that it's properly locked so that it doesn't slide off. That is what we do that is the importance of, you have to ensure that your solar panels are well fastened on the rail so that it doesn't fall off. Because if it falls off, and fire incidents will even be an easier issue to handle. Because if this thing falls off on somebody's head or somebody's, you understand the risk and the hazard associated to this falling off. So that is that for that. Any other question? And you see these rails, please. These rails are actually fastened, screwed at regular intervals on the wooden frame of the building. Please, they are aluminum rails of high quality. Please, we need to be very careful with the quality of materials we use, because if you use an inferior material and you tie these things on them, be sure that tomorrow these materials will definitely fail. And once they fail, your panels are on their own. They will start falling off. So the quality and the thickness of the profile of the material needs to be put into consideration, please. There are so many aluminum profiles in the market, but when you go to buy, please, you need to be very sure of a high quality, thick profile aluminum rail. Why are you doing so? You are trying to reduce the risk of any hazard that may occur from your installation. So please, I don't know if there's any question or any addition.
Yes, so I have a question.
Yes, sir.
Thank you so much for the good explanation on this. However, my question is around this aluminum rails that you have.
Sorry, around?
Are they specifically the aluminum rails that you have, which you install the panels on them?
Yes, sir.
Are these rails specifically designed for this, or they are just some kind of aluminum rails that fit into this work?
Yes.
So let's say now I want to get one.
Yes.
Is it that I will have to specify that it's the aluminum rail for solar panel fixing, or it's just any form of aluminum rails that can be found in the market?
Okay, thank you for the question. It's actually, there are actually some rails, but they are rails specified for this type of job, but you hardly see them in the market. You understand? I remember when I was looking for this thing, because when we started installing solar panels, I was very curious about how my installation should look. You understand? I was because I used to watch on YouTube, I used to watch on online to see how these white people install their solar panels. I was very curious about where I could get their own type of aluminum rails. You understand? Their own type of solar rails. Let me use the word solar rails. I tried to get it, but it wasn't forthcoming. You ask them in the market, they will tell you, no, we actually use angle iron. But I was like, there should be a better way of doing these things that make it look smarter. You understand? So I now started going to aluminum profile people that sell aluminum profile for windows and other things. It was then I discovered that there's a particular frame, there's a particular profile you could actually use that looks exactly like the one I used to see online. It allows you for room to slide your bolts and nuts to tie these things at regular intervals. It allows you that space. And it also has this thick nature, which means it could hold what I want it to hold. You understand? So from there now we started trying it, and it worked pretty well for us. You understand? The only thing is, you could actually get some quality that are not actually good. Those ones will obviously tell you that if you use such, you understand, it could actually, if there's wind can actually uproot your solar panels. You understand? So we actually get these profiles from people that sell aluminium materials for windows and doors, or aluminium works. That's where we get them. They are not, the ones we majorly use now are not specifically designed for solar, but because we've improvised, we've seen that it could do the work. And we also look at the thickness of the profile. It could actually withstand what we want it to withstand. So we now continued using it. So I don't know if it's clear.
Yeah, it's clear. Thank you.
Any other question or addition?
You are perforating somebody's roof.
Yes.
Is there any kind of sealant that you normally use to stop the leakage, or the screws are enough to stop?
Thank you very much for this question, Ogahela. What we actually do is we carry
the leakage.
Yeah, what we actually do is we actually, once we at any point we use screw to tie our aluminum rail to the wooden frame of the roof. We also use a silicone gum to now around the screw at the point of contact with the roofing sheet. We cover it round so that water doesn't actually what do we call it? Doesn't penetrate and cause leakage, or pass and cause leakage. So I don't know if it's clear.
Yeah, it may be battling. It may be battling with.
Can you hear me?
Welcome back.
Well, okay, so sorry. I went offline, but I'm back. So any other question concerning that? Any other question?
Did not hear the answer.
Okay, you guys didn't hear. What we said was, you were asking if we perforate the roof and leave it like that. Well, I told you guys that I was saying that what we actually do is, at any point where the screw passes or gets in contact with pierces the aluminum sheets or the roofing sheet, we use a silicone gum, the silicone gum, we use a silicone gum to now cover around that particular place so that there is no leakage, so that if rain falls, it doesn't leak through that side into the building.
Thank you very much, sir.
So now, I think we will go to the next thing. We are actually talking about safety, because okay. So now, fastening, we've talked about. Can you all see the screen? We've talked about proper fastening of solar panels. Now we are on item number 5, proper termination of cables. proper termination of cables. Everything we're doing here is related to safety. So proper termination of cables, we talked about the MC4 connectors. We talked about inspecting the MC4 connector to ensure that it's rust-free, because if it's a new solar panel, you actually don't, you don't have much to worry about that. But if you're using a panel that has been used somewhere, or if you're using a panel that has been used somewhere, or a fairly used panel you purchased, which is very available now in the country, is very available now, you have to check whether there's rust. Those are all steps to ensure that you have a proper termination of cable, you understand? So now, the next thing is, Mr. Goshi asked of whether if we have, if the MC connector is bad, what do we do? I told him that if we have another MC4 connector, we change it. If we don't have, we have to use the cut and join method, you understand? Now, I want us to talk more about proper cable termination, please. For electrical engineers, I don't know. I want somebody to suggest, please, how cables should be married properly for us. Any engineer, electrical engineer in the house, proper marrying of cable or proper termination of joining of cable. Let me use the word joining of cable. How do you properly join cables, you understand, to ensure that it avoids partial contact? Engineer Hela, can you help us there?
Yes, sir. I think you have already given the answer. We use married joint.
Okay, married joint, that is it.
Yes.
Okay, married joint. Let me see if I can Google it online.
So after joining, then there is a particular material that is in form of a solid tape, but is like a gum, like a rubber, that you can tie it around it, then use your solid tape on it.
Okay.
It will insulate it properly.
Okay, so the thing is this. There are two things to it here. First thing first, proper termination of the proper joining of the, what do we call it, of the cable. Then secondly, you talked about okay, I want to share something here. Then secondly, we talked about insulation from water ingress, right? Insulation from water ingress. I'm trying to see if I can, trying to see if I can. There's a particular page I'm trying to come up with, a particular picture. So I don't know if you can all see this picture. Can you see this picture?
No, we are seeing the content of your folder.
Okay, sorry. What of now? Still?
Yes.
Okay, I'm coming. Let me still share. Sorry.
No.
Okay, I'm coming. Now, can you see it?
Married joint.
Yes, it's clear now.
Okay, so you can see married joint, proper wire joining. So that is it, please. For proper, why we do so is because we don't want anything that has to do with partial contact. You know, this is the installation is not. We are doing an installation that is going to be a consumer durable. It's going to be a consumer durable. What it means is that it's going to be consumed for long, or it's going to be used for long. So you are not expected to do a job that you need to be revisiting every now and then. So you have to do a proper job. A proper cables need to be properly joined or married like this. Then when you do this, then you do a proper insulation, just like Hela said. If you're using a sellotape or an insulating material, there are silicone insulating materials you could use. You could use original heat-resistant sellotapes, you understand? You ensure, the most important thing is you try as much as possible to ensure that water doesn't get into these things, you understand? Because we all know what happens when water and water ingress gets in contact with current carrying conductor or electricity or a conductor that has electrical current flowing through it. So if you don't have the MC4 connector and you are compelled to do this thing, you're compelled to join it like this, you have to do it. You have to do a proper cable joining. So that is that. Any other question? Any question? In the absence of none, let's quickly see, because we have few minutes left and I want to see if we can actually, okay, can you see, are you still seeing the, okay, that screen, cool? Okay, I'm coming.
All right, sir. In this regard,
Yes, sir.
can you?
Hello.
Yeah, we're talking about married joint.
Yes, sir.
Married joint or married jointing. What about in an instance?
Hello, we are listening to you, Hela.
Yeah, so what about instance? So, the cable contains like two wire in a strand, 2 or 3.
Okay, when you're talking about multiple cabling.
Yes, multiple cable.
Multiple
There
cables.
are instances where we use what do we call it? I don't know the technical name, but we use this height of the fingers.
Okay.
Height of the fingers, in the sense that one is taller than the other, one is taller than the others. Likewise, the others may be shorter.
Yeah.
Then after marrying them together, then we insulate it.
Okay.
Yes.
That is fine. You understand? The most what I think we need to note from here is we should note that our cable, our joining needs to be firm. You understand? It should be what we need to pick from here is our joint needs to be very firm. It shouldn't be slack. You understand? It shouldn't be slack, because any slack connection will definitely cause partial contact. Let me use the word partial contact. And we all know partial contact are all losses in electrical system, because power doesn't get to where it's supposed to get completely. Let me just use the word completely, because if there's a partial contact, power that is supposed to reach point A from point B, you understand, will definitely reach half, you understand? So the efficiency will definitely drop. That is one aspect of it. Efficiency will be affected. Then the other one, which is the dangerous part of it, is, fire incidents can occur from partial contact. When the partial contact continues, gradually it hits up the insulating medium. The insulating medium obviously with time will then catch fire. You understand? Once it catches fire, we don't know where it could stop. You understand? So efficiency is number 1. 2 is the fire hazard associated to it. So we need to ensure, because of that, we have to ensure that our connections are well fastened, always. Are you with me?
Yeah, we are with you.
Okay. Then the third one I will be talking about is, are you seeing my screen, please? You're seeing?
Yes, yes, I'm with you, sir. I'm with you, sir.
Okay. The third screen was, I think we're on item number 6 now.
Yes, the solar cable part. Solar
cable part. We've talked about it earlier. It's linked to why we should install solar rails, you understand? If we install solar rails, it gives us a lot of a clearance or a suspension under our solar panels where our solar cables can actually follow, you understand? And this clearance will serve as enough, will serve as space for our cable to move conveniently without any pressure on our solar cables that could possibly affect it in the future. Creating space underneath the solar panel, if you remember, I said it helps in pulling off the solar panels itself. Then secondly, that space created underneath will also help. You know, this will help in also creating a path for our solar cables to follow. So I don't know. I don't know. I don't know. The next one is any question again here? I want us to please, I think we will enter the third slide today, but it's going to be, since we have less than a minute left on this meeting. We have less than a minute left. So I want us to quickly rejoin so that we can wrap it up. I will stop this meeting. We'll join the last part of it so that we could quickly talk about the solar panel insulators, because it's a very important, what do we call it? Important aspect of our safety in solar installation.